The total number of positive integer solutions of 21 less than or equal to a plus b plus c less than or equal to 25 is 21 less than or equal to a plus b plus c less than or equal to 25. A, b, c are positive integers. So we're thinking about 21, 22, 23, 24, 25. What I'm going to do, I'm going to say, hey, to simplify this, let me solve for a plus b plus c equal to 21, where a, b, c are natural numbers. There's a standard formula for this, n minus 1, c, r minus 1. I'm going to see if we can arrive at that formula. Imagine this is 21 ones. 21 ones placed on a board like this, or 21 pieces, sticks placed. Right? Then you say, I'm going to take these sticks and put them into 3 baskets. I'll call this basket as A, this is B, this is C. So 1, 2, 3, the first 3 sticks go here, the last 4 sticks go there, the remaining sticks, which should be 14 sticks, go into B. The different ways I can gather these sticks, I get different combinations for A, B, C. All good. So another way of imagining this, the same scenario, so instead of putting them in 3 baskets, I'm practically separating them into 3 piles. First few ones, middle few ones, last few ones. Either sticks or ones, doesn't matter. Or I'm saying effectively, instead of doing this whole stick thing, I can say, I'm going to put some plus symbol in between. If I put a plus symbol here, the first number becomes 3. If I put a plus symbol here, the last number becomes 4, the middle number becomes 14. Or anyway, if you think about it, the number of ways of carving this 21 into 3 parts is nothing but the number of ways of planting plus symbols here. The plus symbols were put here and here. It is 2 plus 2 plus 17. Were put here and here. Probably 1 plus something else plus 3. So the number of ways of breaking it into 3 numbers, 3 natural numbers A, B, C that add up to 21 is nothing but the number of ways of putting those 2 plus symbols in between some 2 ones. How many such slots are there? Between any 2 consecutive ones, there is a slot. There are 21 ones here, so there are 20 such slots. Obviously, I can't put right at the beginning, I cannot put right at the end. Because if I do that, then one of the numbers becomes 0. I want all 3 to be positive. In how many ways can this be done? 20 slots, select 2 of them, 20 C2. So A plus B plus C equal to 21, positive integer solutions is 20 C2, n minus 1, C, R minus 1. In our case, A plus B plus C could be 21, 22, 23, 24, 25. Or the total number of ways of this happening is 20 C2 plus 21 C2 plus 22 C2 plus 23 C2 plus 24 C2. 20 into 19 by 2, 21 into 20 by 2, 22 into 21 by 2, 23 into 22 by 2, 24 into 23 by 2. 19 into 10, 190, 21 into 10, 210, these 2 add up to 400, 21 into 11, 231, 23 into 11, 253, 23 into 12, 253 plus 23, 276. These 2 add up to 400, I can add just these 3, 9 plus 1, 10, 0, 1, 3, 5, 1, 8, 13, 16, 6, 1, 3, 5, 7, 760 plus 400, 1160. Very nice, very simple question. Once you know the framework n minus 1, C, R minus 1, this becomes super cool, super straightforward.